Welcome everyone to the Tulsa.net user group. Tonight, Santosh Hari going to be talking with us about the 10 things .NET developers need to know while using CosmosDB API for NoSQL. Santosh, thank you so much for being here tonight. Greatly appreciate this. You and I have spoken at other conferences together, and I've been able to see some of your other presentations. You're a fantastic guy. Thank you so much for being here tonight. I'll let you take it away from here.
Thanks, Sean. Just want to make sure everyone can see the screen fine. All right, cool. So, Sean's intro was too kind. I'm just a guy who works for Microsoft. My role at Microsoft is called customer engineer or ACE engineer. We have like 10,000 names for the same role, but in short, I am working a very customer-facing role. I come from a extensive consulting and startup background. I used to be a Azure MVP from 2016 to 2020 before I joined Microsoft. And I am also kind of involved, but by backing off a little because of a move recently with the Orlando.NET user group and Orlando Code Camp, which is usually in Feb or March. Great time to be in Orlando if you want to check that out. The talks, today's talk, content and code. You can do a QR code and go to the page. Hopefully it takes you to the right page. Hopefully I didn't put in an incorrect link or something, but feel free to click on this. There's the big short URL. I also dropped the URL in chat. It's the same content as I'm presenting, or at least 90% of what I'm presenting. So, before I get started with today's talk, I wanted to quickly, touch on why I'm doing this. So this is kind of a, brand new talk. I've been a .NET developer for since .NET 1.0, but these days I don't write too much .NET code. I am mostly doing Azure stuff, but a lot of my customers, they write .NET code. So in my role, these days I'm actually specializing in CosmosDB. So as I go and deal with customers and look at what they're doing, I kind of have some takeaways on, these are some of the common takeaways or questions that I'm trying to answer that customers have. So I stop at 10 because I only have, I think I have an hour, right? So I stop at 10, but this could easily be 15 or even 20 if I choose to. So I'm hoping to do a part 2 of this one. I would love some feedback if you want to see more, if you want to see less, if you can hit me up after this talk, just unmute and say, hey, this was garbage. We need to get more or something else. I'm happy to rewrite this talk. It's not a big deal at all. So there's some of the questions that I want to address, and I've numbered these so that we know I'm addressing 10 questions. And I will try to make it in an hour. If we don't, we'll rush through a little bit at the end, but everything is available. All the content is available at the link. So what is CosmosDB, right? CosmosDB is basically a fully managed database service. It's a Azure-only service. With CosmosDB, you can store NoSQL data, you can store relational data, and you can store vector data these days for AI, the big bad AI. So not only can you store these, not just for data storage, but the claim to fame for Cosmos is that you can perform reads and writes with single-digit millisecond latency. So what does this mean? So if I have an application hosted in Azure East, and I have my Cosmos DB in Azure East, if I do a simple read operation, it should return within less than 10 milliseconds. Like that's fast. Think about that, right? So if you do concurrent operations, or if I do 1,000 consecutive operations or 100 consecutive operations, that should be in less than a second. So that's pretty fantastic if you think about it. So the other claim to fame is CosmosDB is globally distributable. So you can, with the click of a button, although I recommend not using Portal to provision stuff. It's always good to use infrastructure as code, but with the click of a button, you can spin up multiple regions. This can also get expensive, but I digress. And you can create a Cosmos database where you can not only create, distribute it in multiple regions, but you can write to multiple regions. So think this is pretty powerful, right? So if I have, let's say I have a Facebook type operation that's all over the world. So I can put up a Cosmos instance in Australia, one in Southeast Asia, one in Europe, one in North America. And when customers from those geographies log in, they can write to the nearest, nearest region, which makes it super fast. So that's, and we'll be talking about that during this talk. So you get Azure-based availability like 5 nines, get all the good security features like Azure AD or Entra, as they call it these days, and Key Vault integration. So with Cosmos, the way to think about this is a database service. It can store multiple models of data, as you can see on the screen. And it is basically what you're doing is you're connecting to an API to handle your data. Hopefully that's a good, decent understanding of Cosmos. So, one of the types of data Cosmos can store is Postgres. So, you can store relational data models using the Postgres SQL API. So with this, you can actually store relational data. You can leverage your existing SQL skills. It provides transactional support. So if you are familiar with ACID transactions for SQL data, you can certainly do that with the Postgres API. And then, it also integrates with other Azure services like functions and such. Vector data. So this is all the rage these days, and I will not be talking about this. So vector data is basically, Cosmos DB has introduced the vector data capabilities, particularly for AI and machine learning. You can do vector embeddings, which means storing and managing high dimensional embeddings for data like text and images and audio for AI. You can do vector search, which means similarity-based searches using vector distance and similarity algorithms. And not only can you do this, but you can also use the Cosmos's inbuilt features like super low latency, fast recalls, and so on. And then you can also integrate your vector data with your NoSQL data and your relational database. So that's pretty powerful. And finally, this is what I'll be focusing on today, which is the NoSQL data. So you can store multiple types of NoSQL data. And the one at the top, which is the native API for NoSQL, that's the one I'll be focusing on. You also have MongoDB, Cassandra, let's see, Gremlin, Table API, and so on. So the other great thing is, with most NoSQL databases, you often get like, eventual consistency that we're talking about, or, somewhere in between. But Cosmos gives you like 5 well-defined consistency models. And I'll be touching on that today. So this is kind of like a fast-paced walk through Cosmos, if you think about it. So the next question is, people ask me, should I move all my data to NoSQL? And the answer is, it depends. I'm a consultant. I'll always say it depends. So it depends on things like, whether you're looking for high availability, low latency, and scalability for your data. So there is this thing in NoSQL called 3 Vs, which is velocity, variety, and volume. If it matches any of those, it's usually a pretty decent fit. For instance, IoT, right? IoT generates massive amount of data from different types of devices. They have some kind of commonality like the device ID, and they need to be ingested and processed in real time. So Cosmos is a good use case for that. Retail applications, they often require like real-time inventory management, customer personalized experiences, transactional processing, and so on. And again, the word real time, right? So Cosmos is a great fit for that. I've also seen Cosmos used for online gaming. So a lot of games use Cosmos DB as the backend database because you need to manage player data, sync it across the globe in less than a few seconds or milliseconds, and uh, you often require like fast reaction to whatever actions you're performing. So this would be World of Warcraft uses Cosmos. There used to be the Walking Dead game that also you used Cosmos. There's like other ones also, I forget. So those are some great use cases, right? So if it fits these, you should definitely go for Cosmos, and I'll speed up a little. So one thing to think about Cosmos is your workload that you're doing. Is it read heavy? What is a read heavy workload, right? It involves a high volume of read operations. So think like reporting software, right? So reporting software is just read. You're not writing with reporting software. So that's, if you're doing a large volume of reporting, Cosmos is a great fit. The challenges with read heavy or query heavy databases is that you have to keep an eye on the indexing strategy. The complex queries become slow as the data set size grows, which requires constant optimization. And then queries can perform differently at different volumes. So you could have a query that works great for small volume of data, and then you suddenly increase it tenfold, 100-fold, and it just creaks along. So those are so read heavy workloads, Cosmos is a great fit. Next is write heavy workloads. So these workloads often involve a high volume of write operations such as logging, telemetry, or real-time data ingestion. You have to ensure that all the writes are accurately recorded and data integrity is maintained. And the system must handle high throughput of write operations without locking or significant delays. Cosmos is a great fit for that. Keep in mind that I presented these two separately, so read heavy and write heavy. So one of the things to consider is that when you're using Cosmos, when you're using a Cosmos database and considering how to do it, you should not combine those two. If you combine those two, that's not a great scenario to be in. Okay, so how migrating relational to NoSQL data, right? So how do you do that? I would say you shouldn't migrate the whole thing. You should use well-recognized patterns like Strangler Fig. But in Strangler Fig, we usually use that in architecture, like system architecture, where we take small pieces and abstract it away and then change it underneath. So use a similar type of pattern in Cosmos. So basically, you start by identifying components, determine which parts of the legacy database can be replaced first. Then you create, on the front end, you create a facade that intercepts the requests to the legacy system and routes them either to the old or the new system based on the functionality. You can incrementally replace the underneath data and basically replace the old storage with the new storage. So let's say your old storage is CSV and you're using Cosmos. That's a great way to do it, or just SQL Server and Cosmos, or whichever one, right? So, and then finally, you have to keep in mind that you decommission the legacy system. So moving your data, you have to consider all of these things. So your next question is, where should I store my data and how do I access it in Cosmos? So this is what your Cosmos system looks like. You have a database. When you create a database or a Cosmos resource, you get something called a database account. A database account has like a logical container called database that can hold multiple containers. Now, when I say containers, it's not like Docker container, it's a container of data. So that is where your data is stored, is in containers. So you'll hear the term containers. You may hear the term collection or table or graph. All of these are basically containers of data. So it can get a little confusing when you're in Cosmos, because people may say container or people may say collection, but keep in mind it's the same thing, and it's not a Docker container. One thing to remember, when this is where containers where all the data is stored. So you'll kind of see in here that, you have a container, you have stored, you have items, which is the actual data, but you also have things like stored procedures, user-defined functions, and merge procedures, and so on. All of these are like little management tools. It comes from the SQL Server world, because back in the day, when Cosmos was created, before it was created, it used to be document DB, and that document DB tried to, as much as possible, bring over some of the SQL Server components. But these are still pretty useful these days, like stored procedure. We will not be talking about these today because of the shortage of time, but again, if I do a part 2 of these, I'm happy to delve into detail in these. One thing to keep in mind, you don't start incurring charges unless and until you create a container. So you can basically stand up a Cosmos resource with a database account and really not get charged anything. But the moment you start adding containers, your bill goes way up. So keep that in mind. How to access the data. So this is, it's a little, I know, complicated. And I say complicated because when you create an account, you create, in the previous slide, we had the database account. So when you create a database account, you get a URL or DNS name, right? And you can use this to connect your data. Now, when you do this, you also get something called a primary, connection string that has a primary key and so on. But generally, this is great for development. But when you go to production, don't use connection strings. If this was like an open talk in a classroom or something, I would say, please repeat after me, don't use connection strings. The best way to kind of look at this is, if you cannot avoid using a connection string, store that in a key vault in Azure, and then pull it from there using some kind of managed identity, something like that. So as far as possible, avoid connection strings. Instead, when you deploy to Azure, in Azure has a feature called managed identity. So let's say you deploy like container, like a container in AKS, or you have a web app or something. You can create a managed identity for that and give that managed identity access to your Cosmos database, and that's how you should be pulling your data. Again, if there are questions, feel free to drop them and I'll be happy to answer. Or Shawnee can even chime in. I don't mind being interrupted. So, a few things to keep in mind. The containers store the data by scaling up. So, this is a container of data, right? So you can store practically unlimited data. I've seen like their containers of data as big as 200 terabytes or so on. So it does get a little tricky when you store large amounts of data, but that is a whole discussion for a different day. But you can, for our purpose, most people that we know probably store like gigabytes of data. Some store terabytes of data, and if you're like 10, 15 terabytes, that's nothing. So you can store a lot of data with a Cosmos. So it's stored in something called partitions. There are two types of partitions. So this is another thing to remember. There are physical partitions and logical partitions to deal with in Cosmos. So when someone says, I'm just saying, when provisioning Cosmos, you need to provide a partition key. That is a director to your logical partition. So a partition key points to your logical partition, and that is the one that you can manipulate. Now, the whole concept of physical partition comes from NoSQL data being stored on multiple machines, not just a single machine. So each machine is kind of like a physical partition. So the way to think about this is, I can take a Cosmos, I can create a Cosmos container, it with a partition key. It has logical partitions. Each logical partition can store up to 20 GB. If at any point your partition key that makes the data exceed 20 GB, that's a bad design. You'll have to immediately migrate to, use migration techniques to alleviate that. And I'm happy to talk about that after the talk if we want to, and how to deal with that. And multiple logical partitions are stored on a physical partition, which is the actual machine. So a physical partition can store up to 50 gigabytes of data. And it uses some kind of hash-based partitioning technique to spread logical partitions across physical partitions. So I was talking about the partition key, right? So the partition key is basically something that tells your data, which logical partition to go in. And when you have a partition key and you store your data using the partition key and you write a query using the partition key, this makes it super fast to store and retrieve. So that is where so if your query in Cosmos doesn't have a partition key, it usually is running slow. Just keep that in mind. You can use most fields. So Cosmos data is stored as documents, and I'll show you what a document looks like in a minute. But you can practically use any field that is a string for a partition key. You can use numbers. There is some caveats to that, but never use a double. Like integer should be fine. Never use a double. So keep in mind that once you create, like let's say I take my device ID as a partition key for my container, I can never replace that through the lifecycle of that container. So if I need to change that, I'll have to create a new one. So the choice is very important, and you have to do some data modeling techniques. And just in time for that, I'll also be giving a breeze through walk of that. So use strings. Don't use doubles. They should have a high cardinality. In other words, the property, the partition key should spread the data equally across, across the container. If you get it wrong, you will experience poor performance and have to perform data migration.
Hey, Santosh.
Yeah.
Hey, I wanted to point out something on the ID field that I've talked to a lot of people about Cosmos, and they had a kind of an interesting misunderstanding because they're trying to, usually coming from SQL Server or Oracle or something like that, where an ID field is used to generate an ID, something like self-incrementing, and Cosmos doesn't do that. So the advice that I've given, and you correct me if you think I'm wrong, is the advice I've given is you need to come up with a client side ID, be it a GUID, be it a combination of a GUID and a customer number, or something to that effect, so that helps create that uniqueness, but it has to be supplied so that it's not an auto incrementing number. And I apologize if you had already said that. I was on two different things, but I want to get your thoughts on that as well.
No, that is 100% accurate, and thanks for bringing that up. In fact, I should probably add that to my slides for the next talk. Yes, you definitely, it's not like an auto incrementing thing. You can make it auto incrementing from your code. It's not handled by Cosmos. So, just keep an eye on that. ID field, the other thing is ID field is, it's not, it's like a unique resource. It has to be unique, right? So you can think of it this way, right? It's basically store in Cosmos is a document, so it can be accessed as a fully formed URI. So the ID field is what makes it unique. You should be able to provide a URI that is access to your individual record, and that so it's basically, and you can make your application handle that, I would say. Thanks for bringing that up, Sean. And we talked about read heavy and write heavy workloads. So for read, when it comes to read heavy workloads, you may partition key. In fact, you should choose a partition key that appears frequently in your queries. So write heavy, it's the same way. It's like choose a partition key that spreads the data equally. So let's say a bunch of IoT devices light up and they send millions of records per second. You may want to separate by something like device ID or something. Don't use like the hour of the day, because you'll get like a million records coming in at the same time to the same partition. You don't want that. You want to spread it out equally. So what does the data look like? The data looks like JSON. So it's data stored in JSON document. So the only two fields that are required are the ID field and the partition key. In this case, I'm using the user ID as partition. So those are the only two fields required for any Cosmos record. After you add the record, you will see a bunch of extra fields that get added. And those are automatically added by the system. Those are, one of them provides a link to provides a unique link to the resource. The other one deals with concurrency and so on. So you don't have to deal with this, but you only need these two. The rest can be anything, literally anything. And this is one of the great advantages of NoSQL data. Speaking of which, schema agnostic, CosmosDB and NoSQL store is schema agnostic. You can store different types of document within the same container without a predefined schema. For people coming from the SQL world, this is a huge culture shock. Excuse me. So the flexibility allows you to evolve your data model without downtime. So for instance, here I have a ID field and a user ID, right? That's my partition key and my ID. Keep in mind that if you choose your ID as the partition, you don't even need this other field. So you'll see that my second document also has ID and user ID, but these are pretty, drastically different documents in terms of schema, and you can store those within the same container with zero issues. So that really helps. But but you have to also consider that when you are querying data, like if I say that where items.product ID equal to P1, it'll only pull this record, and it's not even going to touch this record. And we'll see how it does that in a minute. But it's super flexible, and I really love this because I can evolve my databases without like really having to worry about the schema. And the way these fields, these databases can be completely different is because of this unique indexing mechanism. So you'll see that in here, there's a locations, country, city. There's like an array on here. There's headquarters, country, Belgium, and exports, city, Moscow, and so on, right? So you can take this document, and when you store it in Cosmos, it goes through an indexing process in which each of these top level items are then indexed based on how they come in. So for instance, this one is an array. Locations is an array, so you get 0 and 1 for each index for the array. Headquarters is simply an object, so you get it as a simple object in here. And similarly, export is an array. So I could write a query saying where exports, exports dot city equal to Moscow, and it knows how to do that by simply going to the exports part and traversing this tree to find the Moscow record. So, and it'll only pull that one. So it'll not pull like headquarters or anything like that. So that's kind of a great way of indexing data that makes it really easy to pull. Keep in mind that by default Cosmos indexes every single record and every single field you store in it. You can tweak it to not do that because indexing does cost does slow down the operations a little bit. So if you have like a huge blob of data incoming, you may want to say, I don't want to index all the fields. I only want to index on certain fields, and that's perfectly fine. It's just going to be hard to use them in the where clause of a query later on if you choose to not index them. So, but by not indexing them, you can make your write operations super fast. So now, next question, how do I convert relational data to NoSQL? You use a process called denormalization. So in a relational database, you can see that data is typically normalized to reduce redundancy and ensure data integrity. And this is the world that I grew up in. Most people, most old timers probably come from this relational data world, and it's kind of a little bit of a jump, right? So suddenly you're telling me to flatten my data. What the heck, right? Relational, basically normalizing is splitting the data into multiple tables, to store a single record that I could create as JSON. I'm having to store that in multiple columns in I'm storing it as 4 records across 3 different tables, and I'm having to write a query that joins all this. So, this is a great way of doing it. If SQL has its own use cases. Don't get me wrong. You should use SQL where the use case is right. But also, like if you're looking for something that is of this format, you could, if the data is not changing often, you could store it as a document and retrieve it. So to start thinking about denormalizing your data, and this is a challenge to everyone on this call, right? You just go home, take a look at your database, see what can be denormalized. If your data is not changing, why not store it as a document data? So just take a look at that. So when you have 2 ways of denormalizing. The first one is called embedding. So you can choose between embedding or referencing, and each approach has its own advantages and use case. Embedding involves storing related data. So I have orders, for a customer, I have the orders and items in the order, and I'm kind of embedding that all of those under the customer record itself. This is useful when related data is accessed together, and it's also useful when the data doesn't change frequently. So, you should probably create this record after someone has placed the order. Do not create this when someone is still filling their cart, because that could change constantly, right? Like I always add and remove items from my cart. So after I place my order, if I store this, it's pretty close to the final format. Yeah, in some cases you may go back and change your order, but that's a new order at that point. So just start thinking about it in that form. The other way to denormalize is by referencing your data. So referencing involves storing related data in separate documents and using references like IDs to link them. So this is useful when the data changes frequently or grows without bounds. So think about my social media profile, right? And I'm making posts on my social media profile. This doesn't have this is constantly changing. Like I could make 100 posts today and go silent tomorrow. And it has no upper bound. So if I'm a chatty person, I can make like hundreds of posts per day. And I don't want to be embedding that kind of data. So that is when you use the referencing technique. So I would have like, my social media profile, and then I would have post IDs in here instead of embedding the whole data. So that is another way of denormalizing. So those, when you're denormalizing, you can use any of these two techniques. The most common one, if it's not changing often, is embedding. If it's changing often, is referencing. So again, these are the pros and cons, but we kind of talked about this. So I'll move on. So how does, now we get to the .NET part, right? How does a .NET developer perform CRUD? To do that, what I'll do is I have my code on my page itself. So on the links that are provided at the beginning of the talk. So you can go back and, if you download that code in the source folder under web, you should find the code that I'm about to talk about. So this is very simple one, right? So this is basically, I took the sample code from the Cosmos website itself, but I made some minor modifications to it to help with my talk. So, a few things I want to talk about, and this is, oops. Yeah, so we'll talk about a few things on here, right? So first thing is SDK, .NET SDK. So which version should I use? So the current minimum recommended is 3.35.4. So always use the latest .NET SDK. So if you're starting a project today, don't even think about it. You may find a code sample that uses SDK version 2. Please do not use that. Use the latest version, at least use the minimum recommended version. And you can find information about that if you go to the Microsoft pages. And you can add Cosmos to any project by using the .NET Add package, microsoft.azure.cosmos. So that would get you something like this. So the next thing I want to quickly talk about is, okay, so we'll dive into code. So this is very simple code I'm using for today's talk. Again, time constraints and such. So in this code, you'll see that I'm using the Microsoft.azure.cosmos library, that package that I added to the project and in a program class. I'm checking if it's in development. If it's in development, I'm using the connection string, which I tell people never to use. But in development, I can do something like .NET secrets and put in the connection string, right? So it's just local to my machine. So I'm using this in connection string. I'm instantiating something called a Cosmos client. You will see that I am doing it as a singleton, right? And I will tell you why in a couple of minutes. But you'll also see that when I'm not in development mode, I'm using something, I'm using the endpoint, and then I'm connecting with the Azure managed identity. So my expectation is that, again, this code sample has everything, including configuring the infrastructure and such. So when you configure the infrastructure and deploy this to Azure, your application runs as a Azure resource, and you can use the managed identity of that resource. Again, this is a Docker file, so you can upload this as an image to your container registry, and you can pull it into Azure Web Apps or AKS, whatever it is. So long story short, development connection string is fine. If I'm not in development, I probably want to use Azure managed identity. Again, so that and the other thing to pay attention in here is singleton. I'm adding it as a singleton. Now let's jump to the actual service that uses this. So in here, I have Cosmos service. Sorry, iCosmosDB service. Again, this is just an interface. You can see that it's just running a console app type service. So what it's doing in here is it's pulling in the Cosmos client. Keep in mind, the Cosmos client is a singleton, which means that it will only exist for the lifetime of this application. And it uses a single client for the lifetime of this application. When this lifetime of this application ends, the connection will, or the client will die. But until then, it uses this client. So then, when I run this application, it performs a few things. In the first instance, it's doing a somewhat of a silly call saying create database if not exists async, and then it's creating a database, right? So we'll talk about this create database if not exists async and why does it do that. But essentially, it creates a database if it doesn't exist. Similarly, it creates a container. Again, you have the database and then you have the container, and the container is the one that actually stores the data. So it creates a container. This is the name of the container, and this is the partition key in the container. So when you create a container, I always have to specify the partition key. So when these two are created, I am creating an item. Again, this is just using a dynamic. And doing a couple of things in here, right? So it's doing a container dot should have probably been insert, but let's see if I have it. Okay, so this should have probably been an insert itemizing. So you can do two types of operations. One is called an insert and one is called an upsert. And again, I'll talk about that, but essentially insert writes the data as if it were a new record every time, and upsert actually checks to see if the data exists, and it will replace an existing field if that doesn't mean. Again, like Sean mentioned, the ID, I'm actually specifying the ID in my code. So this is simple CRUD, right? I'm creating a database, creating a container. This is inserting it or updating it. And you'll see some things like, it's looking at the request charge and so on. And finally, it's reading the item. And the way it's reading the item is it's using a read item call, and it's passing in the ID, and that should return the item that was stored. So that is the expectation here. So you'll also see that I'm running a query. So this is, and we'll see what all of this means shortly. But I can read an item using the ID, or I can run a query that pulls in multiple items. All right, so I'll jump back to my code and I'll run this at the end and put the pieces together. So we talked about the Cosmos client. Now singleton, what is the whole concept of why am I doing it as a singleton, right? So Cosmos client is it's a thread safe class. It is recommended to create a single instance of Cosmos client for a lifetime of the application. This enables efficient connection management. So what happens when I don't use singleton? I get a lot of these questions, or I don't get these questions, but I actually go in and you'll see that the customer is basically experiencing something called a thread pool starvation, and I'll be like, did you use singleton? And usually the answer is no. And that is why you should use singleton. If you don't use a singleton, each new instance of Cosmos client, it'll be initializing itself, which increases the latency of your operations. You'll experience something called resource exhaustion, which means that each time you run this, each time you instantiate a Cosmos client, it opens a new connection. So you'll start to run into resource exhaustion. There's something called a thread pool starvation. If multiple Cosmos client instances running synchronously, it will lead to thread pool starvation because synchronous operations block threads. This reduces the availability of threads for other tasks. So this is especially relevant in the world of containers. You will experience thread pool starvation, not just in containers, but also I've seen it happen in things like Azure web apps, right? And functions. People do, they just open up, don't use singletons for the client, and then they run into thread pool starvation. So these are some of the downsides of doing that. Again, going back to the code, there is you could use create, but you notice that I was using create if not exists. So what does it create not exist do? I use that for the database and I use that for the collection. What it does is it checks if a database exists, and if it doesn't exist, it creates it. That's actually a great way of doing it. It's just defensive programming techniques. You could completely skip create if not exists, and you could write code that does try catch on the create. So in this, it tries to create the database, and because the database doesn't exist, it'll throw an exception, so you can catch the exception and handle it. I'm lazy. I choose not to do that, so I will use create database if not exists. But keep in mind, create database if not exists is an expensive call, because every time you run it, it'll check if the database is created or not. So you should use this as less frequently as possible, preferably once per application lifecycle, like your at least use it less frequently than your queries. Hopefully that makes sense. We saw create item async, and actually I changed my code, so you did not see create item async, but this is what a create item async looks like. It's very similar to the absurd item async. The advantage, if you use create item async and you try to create a record, and let's say you specified the same ID field, it will throw an exception. So when you use create item async, you have to use try catch code to ensure that if you're inserting duplicate records, you handle that exception. But if you don't want to do that, again, I am lazy, so I choose to use absurd item async. Again, absurd is an operation that check if that record exists, if the record with that ID exists, and if it exists, it will simply replace it. If it doesn't exist, it will insert it, which is a fantastic way of doing it. But the other thing is absurd is idempotent. So basically, it's safe to call multiple times. It will never create a duplicate. And it handles both inserts and updates. One thing to keep in mind, it's expensive. So everything comes with a trade-off. So the other thing we looked in our code was read item async, in which I used the ID to invoke a record. And then I also used a select query, in which I actually wrote out a select statement. So this is kind of like a SQL select statement, right? Selects asterisk from C, where C.id equal to blah, 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 and C.partition key equal to blah, blah, blah. So that is, there are two different ways of doing this. One thing to keep in mind, ID is the less expensive operation. So if I want to quickly invoke a record, I invoke one record, I will use the read item async. It's in the name. It says item, single item. But if I wanted to pull multiple records, I'll use a query. There's no right or wrong way to do this. You just have to do it by the use case. So I'll talk a few more things about the Cosmos platform in general and how it impacts your .NET code. The first thing is, this is in the global distribution section. Remember I told you that you can click on a map and spin up more Cosmos instances. These are some of the items you have to deal with. You have to consider the consistency. I see a bunch of questions in here. Sean, am I missing anything? Do I need to answer any questions quickly?
No, I've been handling most of the questions since they were going to take a little detail on there. So I was handling most of them.
Yeah. So I'll answer the last one. So
Sure.
Rob, your question is SQL syntax work with vector DBs. It does not. So Mongo is kind of similar. Mongo and the NoSQL syntax is kind of similar. So you can probably pull that off. But Cassandra has something called CQL, Cassandra Query Language. So you will have to learn CQL. Similarly, the graph database has its own query language. I think it's Gremlin, Gremlin query language or something of that sort. So you'd have to learn each individual language, but uh, that's not the, I think where we should focus on is provisioning a Cassandra account, provisioning a graph database, provisioning a NoSQL database is practically the same. So you can provision those in Cosmos, and I can provision an application, use the managed identity to access all of those three. So that's the whole appeal of using Cosmos. So I can say that this same ID has access to all of those three databases. So, and because they're all co-located, you can pull data from them real fast and combine them. So there's a lot of goodness to doing that. Anyway, I digress. Consistency, you have to pick one. Usually when you provision Cosmos, it gets provisioned with the session consistency, which is the default. If you don't know which one to use, I always recommend sticking with the default. You cannot go wrong with session consistency in about 90% of your use cases. The strong consistency, if you want it to work similar to a relational database, where you write something and you read it and you get that across the system, that's strong consistency. So you should, like financial transactions, you should use strong consistency. Session consistency is different. It's strong consistency, but it's only within a certain session. So if you have like a user or application session, you can make it, and that session writes to the database and it reads the data. You can get strong consistency within that session. So that is session consistency. Eventual consistency is, I write it and then you read it at some point. That's what NoSQL used to be. It's each has its good and bad parts, and so it's and you have to pick and choose based on your use cases. A lot of times, people usually just stick with session. You can in this map click on multiple regions and simply provision your Cosmos accounts over there. You can also say that, hey, I am a stock exchange based in New York City. I want people all over the world to read my data, but I only want to write in New York. I only want the data to be written in New York. That is fine. That is a single write, multi-read region type of single write region, multi-read region deployment. And that is one use case. The other one is I am a social media application and I have customers all over the world, and I am going to spin up write regions on each corner of the world. So I'm going to spin up one in Australia, one in Southeast Asia, one in Europe, a couple in North America, one in South America. And each of these, when a customer from Australia logs in and they write, they will write to the region in Australia. So that is a multi-write region deployment. Again, based on the use case, each has its, like multi-write region can also be more expensive. So again, there's no right or wrong answer. You pick based on your use case. So a couple of things you should consider. If you're doing a single write region, you should probably, in your application code, specify which region is your write region so that the Cosmos SDK is not going out and doing a search every time it has to do the write. So this operation is actually pretty fast, but it's better to specify it when possible. So this top code in here is for single write region. Again, I'm highlighting it. Hopefully it comes across on the screen. When you're doing a multi-write region, you can specify the order in which you want to be your preferred write regions in order. So I can say that I want my applications, since most of my customers are in US, I want most of my writes to go to West US. and then North Europe, and then Southeast Asia. This also helps, like, if West US goes down, it'll automatically start sending writes to North Europe. So another thing that people never talk about is what happens when something goes down. And these days, Azure doesn't, the way you see things have issues in Azure is usually it's regional. So I may have an issue in West US and I may not be able to write to it for a while. So if I have my code configured, I don't have to worry about my applications doing something silly. The other thing I always recommend is always co-locate your application with your write region, because that is the only way you can achieve those fast latency, like low latencies to write and read from your application. Next question, how do I measure my performance? So I keep talking about all these, slow latency and so on, right? How do I do this? It's something called request units. There is, people have told me that this should probably appear earlier in the talk, and I would be interested in knowing, this audience feedback on whether it should appear earlier or later. So request units are basically the currency for throughput and Cosmos DB. They abstract the system resources like CPU, IOPS, memory, and so on that are required to perform the database operation. And it kind of puts a number to it. So each operation, whether it's read, write, or query, or even delete, consumes a certain number of resource units based on its complexity. So I did a read item async. If I did a read item async, which is for a single document, and the document is 1 kilobyte, that costs me 1 resource unit. So that's kind of the ways to think about it. So that really helps when measuring how I want to provision it, right? So the same thing when I try to write that document, it costs me 5 resource units. And when I do a query, it depends. Like my query could be really great and it could pull by ID, and that would be 1 resource unit, or it may pull by a name field. It may do a text scan, and that could be like 25 resource units. So when I say, when people tell me my queries are running slow, I first check to see what's in the query. Are they using an ID? Are they using a partition key? If not, usually that's a red flag. How to estimate when you're provisioning your Cosmos, how to estimate your resource units. So in your, again, I will do this shortly. How much time do I have, Sean?
Oh, you're good, man. You're not limited.
Okay, great. So I'll keep going. So you can run. So when you're doing development, you're usually good to turn on your debug and calculate how much each operation is costing, and you can use this to measure. You use this to provision your Cosmos database when you are getting ready to go to production. And keep in mind that the first time you'll probably get it wrong, but Cosmos also makes it easy to scale up. And the other thing to keep in mind, we make it easy to scale up. We also charge you money. So that's always a double-edged sword. So this is an example, right? So you do a select from the table where name equal to blah, blah, blah. So this is not using an ID. So this resource unit for 1 single run is 26 RUs, right? And I'm estimating that I'm going to be, my application is going to need 100 of these type of queries per second. So I will say that I need approximately 2600 RUs. So now I'll take a collection of all the queries that I'm running and my expected usage, and I'll add them up, and that's what I'll use in provisioning my Cosmos database. You can obtain, again, this was in the code we saw earlier, is the property called request charge. So when you perform any kind of CRUD operation, get a response, when you do the response.request, that gives you the amount of RUs that particular operation cost. So the next question, what happens when I provision, let's say, 10,000 RUs and suddenly I run out of it, right? I did not estimate correctly. I ran out of it. So when you run out of your provision RUs, you get this beautiful message. And because Cosmos is an API, all of these messages are often HTTP status codes that you'll recognize. So you'll see 503, you'll see 408, you'll see 429. Usually, most of the customers they see 429 because that there's some kind of miscalculation. 429 means that my I'm basically exceeding my provisioned request units, but it also tells me, hey, by the way, it's okay. You're okay to, you're okay. You can come back after 100 milliseconds and retry this query. And at that point, if I'm not busy, I'll give you a response. So that's what this message is telling me. So when you see 429 and request too large, always look at the retry after. And you can potentially retry, and if your system is not loaded, you should be able to get a response to your query. So it does make it pretty friendly in that way. Let's see. Okay, so speaking of backoffs and retry, the .NET SDK, when you throws a 429, the .NET SDK itself will catch this. It will respect the server specified, the server specified retry after header and retry the request. Now, if your account is still backfilled at that point, or there's too much traffic, then your retry will fail. But you want to talk about how to, when you're retrying, you also want to talk about backups. So if you have more than one client cumulatively operating above the request rate, you can set the default retry attempts. I think the default is 9. You can certainly shorten it to 3. So you can also increase it if you want to do the retry. But usually what we recommend is, you want to retry a few times and then start backing off. So so the other thing is, max retry attempts on throttle requests is set to 3. So in this case, if the request rate is rate limited, which is 429, the request operation retries 3 times before throwing an exception. So the other property in here is max retry wait time in seconds. So this one, when it's set to 60. So in this case, if the cumulative retry wait time in seconds exceeds 60 seconds, it throws an exception. So that's kind of the retry back off implementation in the SDK. We'll quickly touch on these. We did see that whenever we wrote a method, it was an async. Asynchronous allows you to, basically, it allows you to perform other tasks while you're waiting for your IO. So this is particularly important for database operations. So if you're take upsert as an example, right? So when you upsert, it first goes and checks if the record exists. And then based on if the record exists or not, it either inserts a new record or it updates the existing record. So this is kind of somewhat time consuming. So you're writing this as async will help, free up your application to do other things while it's waiting for this IO operation to complete. So along the same lines, it's always good to avoid blocking calls. Now, it's okay to do that in sample code, but using task.result. So this is where your .NET, deep .NET experience comes in, right? Like using task.result, task.wait, and so on. So that's probably not a great programming technique. If you do many synchronous blocking calls, this can lead to the feared thread pool starvation. Cosmos, recently has introduced this thing called Stream API. So this is very important for .NET developers who are writing middleware applications. So the Stream API, what it does is it enables application to receive and return data streams, and it bypasses the need for serialization, deserialization. So think about like billions of records being written per second, right? So, doing serialization and deserialization in middleware is not something you want to. You can probably avoid. If you can avoid that, it would be great, right? So, if the data is handled in its raw form, it can reduce a lot of processing overhead. So this can improve your performance. And again, this makes sure that this, if you're writing middleware or middle tier applications, leverage this Stream API to make sure you get the best performance benefits. Again, we want to talk about when you're reading data at a high volume, you want to talk about parallelization. So there's something called max concurrency. That's a property you can do on your queries, and max buffered item count. So I'll be talking about these two properties when you write your queries. Max concurrency property basically specifies the maximum number of concurrent operations that can be run client side. So during your query execution. So setting this property, again, it controls your parallelism. And the max buffered item count specifies the maximum number of items that can be buffered on the client side during parallel execution. So this kind of helps control the amount of pre-fetched data. So some of the techniques for this is always start with a high value for max concurrency. So you can start with int.max value in your C# code. See if that see if that impacts performance in any way while you're doing queries. If it doesn't, great, just keep it at that. So it's always good to find a good balance between the parallelism and when you start doing high parallelism, you may see high CPU usage. So keep an eye on your CPU usage, particularly if you're running Docker containers and such. And I'll quickly touch on this. And then what we'll do is we'll run the code that I had. I'll show you a few things, and then I'll stop right there. And we can talk about anything after that. So this is when you're using Azure Portal, very few people seem to use the diagnostics section of the Azure portal. Always, when you deploy anything in Azure, always enable the diagnostic settings, especially with Cosmos, enable your diagnostic settings. And here, what I'm doing is I'm writing a query that intentionally creates a 400 error, right? So, and then in here, I'm going to my Azure diagnostics, and I'm checking for status code 400. And it will actually, if I did this correctly, it will show me that this generated a 400 error. So this is a great way to get started. You want to get familiar with your diagnostic logs on your portal when you have Cosmos, so that if you're getting, let's say, a 429 error, you can go in here and pull up data about that using queries like these. So, you may be, it's possible that, as a .NET developer, you may not, be doing this in production, but, doing it on a development account, great way to learn about this. The last point, tracers, some environments have the .NET default tracer enabled. It poses performance issues on production environments, and later SDK versions automatically detect and disable this. If for some reason you're not sure, you can always write code to check if your tracer is enabled and remove your default traces. What I will do is I am going to run this code and show you a few things. And after that, I am done. So I'm running this code in debug mode just to walk through a couple of things. You'll see that I'm in development environment. So let's once this runs, you'll see that it hits the breakpoint and goes into the development environment, which means it uses the Cosmos DB connection string. Of course, running slow as molasses today, but we'll get there. Yep, Azure Resource Graph Explorer. Yep. Okay, so this hits dev environment. So let's kind of walk through this. It goes in, creates a singleton with the connection string. So we'll run this code. And it pulls up this particular web page. And you'll see that it's creating the database. It's creating a container. It's upserting a record, right? And the first upsert is just a simple insert. And this is the request charge. The second one cost about the same. Then I did a read item. You'll see that the read item only cost a single RU as opposed to 20 RUs for the insert. And then I wrote a query, and the query, you can see that it costs more RUs than the read. So just a simple example, just take it, run this in your development environment. One thing to keep in mind when running this, you will have to provision a Cosmos account. By the way, this is where it gets created. So I didn't have the Cosmos database, CosmicWorks database. This is the container. These are the items. Excuse me. You see that it added these fields, and then you have some extra fields that it added at the end. And these are Cosmos specific fields, and they get added every time you create a new record. So I created a Cosmos DB resource on here, and from the Cosmos DB resource, I was using from the keys section, I was using this URI, and because I'm running in development, I was using a connection string. But again, it's great to use in dev. Use managed identity in when you're not running in development. And with that, I will stop and happy to answer questions, or just want to chit chat, any feedback. I know I covered a lot in here. I definitely, encourage you to go to these, download the code, content, read through it, see if it makes sense. I know it's asking a lot, but at the very least, just download this and run the code. It should be fun. All right.
Thank you, Santosh. I greatly appreciate this. Yeah, if you got any questions, you're more than welcome to ask them now. You can come off of mute or put them in the chat. Yeah, I think it was a great example covering a lot of the basis of Cosmos. And we, of course, got the general answer. I say general answer. We got the usual question of how do I know when I should choose a relational versus a non-relational database? You want to give your thoughts on that?
How do I know when to choose a relational versus non-relational? Okay, so there's a few ways to look at this, right? So, so one way to look at a non-relational or NoSQL database is looking at this concept called the 3 V's, which is volume, velocity, and variety. So if you have a volume of data that you need to store, like huge terabyte, multiple terabytes of data, look at a NoSQL data store. If you have variety of data, so like you said, like I showed you some of the examples of flexible schema. So I have like data coming in from 10,000 different types of devices. They only have the device ID as the common field, and everything else is different. That's a variety of data, right? So I don't want to deal with all of that nonsense. So I can look at a NoSQL store. The other is velocity. So let's say in an IoT scenario, my device sensors send me data every 5 minutes, or every 5 minutes, millions of devices all over the world wake up and they bombard my database with data every 5 minutes. So that's velocity. So that, if it fits those three criteria, it's usually a good use case. So that's a great place to start. Again, I would encourage you to go through scenarios like read heavy workloads, write heavy workloads. Is your data constantly changing? Do you need transactional ACID integrity for most of your data operations? If you need ACID transactions, then you should probably be looking at a relational database, not a NoSQL database. So as a consultant, I'll say it depends. Go through all the different scenarios. Don't choose Cosmos because quote unquote it's cool or someone said it's fast. Make sure you have the right reasons in mind. And I said I'll also answer another one of Jeremy's questions. Mr. Sinclair, is he still on there?
Yes.
Okay. So he said it's probably not good as the backend for a blog. Quite the opposite. It's great as the backend for a blog. You just have to make sure that you use those denormalizing techniques of when to embed something versus when to reference something when you are doing the denormalization. I feel like in a blog, once you write a post, you may change a post 100 times before you store it, but then from the moment you finalize it, for perpetuity doesn't change. So that particular record is pretty static. So it's great as a backend for a blog. In fact, I feel like that's a use case that people don't explore as much. I would say, hey, if you want to do it, go for it. I'll be happy to collaborate with you on that.
All right, I got a question that I think other people should be asking if they haven't thought of it, is what if my workload varies through the day? Can I change my RU scaling, and how often?
Okay, good question. Great question, actually. Cosmos DB has this option where you can do auto scaling. So the way auto scaling works is, let's say, again, I'm going to be speaking in terms of RUs, but always happy to translate that. Let's say, I take a look at my workload, and it, I have like 100 users on off-peak hours, but during on-peak hours, I have 1,000 concurrent users. I'm just giving an example. So, I then take a look at my usage patterns, and I'll see that, in off-peak hours, I'm consuming, let's say 10,000 RUs. And during on-peak hours, I'm consuming 100,000 RUs. That is actually fantastic because Cosmos has auto scale, in which you can say that I'm putting it on auto scale. My max is 100,000. So when things start to peak, it'll say that I'm seeing things peaking. I'm gonna start scaling up, and I'm gonna go up to 100,000. I will not go beyond 100,000 because that's the max you'll get charged. But when it's not at peak, it'll start scaling down, and it'll drop to 1/10 of the max, which is 10,000 RUs. So if on the weekends your data is fairly flat, you only get charged 1/10 that amount. But during weekdays, when it goes to 100,000, you get charged whatever the charge for 100,000 is. So yes, it's actually fantastic for that type of scenario. In fact, something I feel like I need to add to my next when I do this presentation the next time.
All right, so I got another item that you might add to your slide deck as well, and that is there for those that want to dabble with Cosmos, is there an emulator and a free tier?
Both. And again, great questions. There is an emulator. You can simply Google, Bing, ChatGPT, CosmosDB emulator, download, and it will give you an installer. I haven't used that in a while. The last time I checked, it was Windows only. It's possible there's a Docker version of it. I'm not sure, but there is a Cosmos emulator you can install locally. It'll give you a connection, you can only use the connection string mode in the emulator. Just that's one caveat. It'll give you a local setup of Cosmos. You can get like a URL and a connection string. It runs locally, connect locally, code against that, and so on. When you provision Cosmos accounts, I think you get up to 1,000 RUs for free per subscription. So let's say you have an Azure subscription. I can provision a free Cosmos account that will allow me to consume up to 1,000 RUs. And I think it's like 25 GB of data or something. I don't use it, so please don't quote me on that. But definitely when you provision, you can choose a free tier. It's only one free account per subscription. But yeah, you can certainly provision a free tier and use that for dev or talks type scenarios.
Yeah, please don't use the emulator for production work. There is no SLA on it.
Please don't use the free tier for production work either. There's no SLA on that. So for production work, always use a production account that is like that you're paying for it. Please pay us when you do production.
Yep. All right, a question coming in. Do you have any opinions on when RUs should be defined specifically on the catalog versus shared across the database?
Oh, great question. So, there is there's ways of provisioning RUs. So, if I don't quite know what each collection is doing at certain points in time, but or my collections are differing usage patterns, but they add up to be about the same, I can cap my throughput provisioning at the database. There's the database at the top, and the database has multiple containers of data, right? So I can provision at I can do my provisioning at the database level and say that this throughput is shared across the multiple containers. On when this should happen, that is good question. So I would say, when you're usually, every time I see it, it's almost always done wrong. The right scenario I've seen this used in is when that let's say you have a data containers that handle data for across the world, right? So North America lights up for 8 hours, and then Europe lights up for 8 hours, Asia lights up for 8 hours, and so on. So each of those could be its individual container that consumes a certain amount of throughput from that is shared across multiple containers. And because they don't always light up at the same time and consume that data, it's I can cap my data at the database level and say that, each container can, take from this pool of shared throughput and use it. And if I do that in a format where they don't light up at the same time, I think that would be a good scenario. But almost always I see it used incorrectly. Could you please give me an example considering practical scenarios, maybe customers, orders? Customer orders, book authors, or something similar. Why would you choose as partition keys and why? Okay, I'll give you a practical scenario, the most practical scenario. Again, I've been talking about this particular scenario because it's the top of my mind, but IoT, yeah, Internet of Things. Internet of Things are devices, you have sensors, right? So consider this scenario that your sensors send data every minute, every hour, and so on. So when my data comes in, I don't want my partition key to be like a city or a country or so on, because that does not distribute the data equally when it comes in. What I want to do is when the data is coming in, like let's say all my devices are waking up every 5 minutes and sending up temperature data. I want this to be equally distributed across the collection. And the only way to do this is to use device ID as the partition key, or something along those lines. Like you should not be using something like day. I've seen people use things like day of the week or something like. It's a horrible idea. You want to use a partition key that will equally distribute. This is a write-heavy workload. Data is coming in simultaneously from millions, maybe billions of devices. I want to spread it equally, so I'm using device ID as the partition key. Now, on the flip side, when I'm doing reports, I'm not going to be querying by device ID. So that at that point, device ID is not a good partition key. When I'm doing reports on these devices, I may flip around and use something like the manufacturer or the device type or or something of that sort, as opposed to using the device ID as the partition key. But that is for a read-heavy workload, not for a write-heavy workload. Hopefully that makes sense. It's not
Well, there's
primarily
times when you might have duplicate data where you have some things that are going to be in your device ID, but some things that maybe even duplicated or summed up, summarized into another partition as well.
Mhm. Can you give me an example? Sorry, Sean. I'm not
Oh,
quite.
well, you're saying like depending on the read patterns, if I'm going to do a report against the devices, I don't want to scan all the devices to grab that information
Mhm.
when I can maybe do that as a batch job, or I could do that on the fly, is storing that kind of data that would be used in a report, store that also someplace else
Mhm.
so that I can help the report query as efficiently as possible,
Right,
cost optimized as possible.
right. Exactly. And the good measuring stick is when you're doing a query, it should use a partition key. If it's not using a partition key, you're especially for does massive size these databases are, you're in for a world of hurt. So uh, try to use a partition key when you're doing queries. So the next question is, so it's not primarily the nature of the intended query layer, but to split. Again, that is it depends on your read heavy versus write heavy workload. Uh, it is primarily the nature of the intended query when you're in read mode. But when you're in write mode, it's more to do with the storage. Hopefully that helps. So this does bring up a question, uh, and there is again multiple ways to attack this. But do I read from the same container that I write to? So let's say I have IoT devices sending data and I'm splitting that by device ID, am I going to run a query against this particular container? And the answer is often not. When it comes in, Cosmos DB has a feature called change feed. It is something that actually monitors for incoming data, and you can react to that incoming data using something called change feed. So people often, what they do is when the data comes in, they listen to the incoming data and they use the change feed to process and store that in a different container so that I can later use it for queries. So don't be ashamed of splitting the data into two different containers when you're doing this. The same data.
And I want to bring up something too, that it's also called schemaless, meaning that one document to another, even the same container, the documents can be of a different schema. They still need to adhere to the, you're right, the partition key, etc. But they can be of different JSON formats. And because I was addressing another question that had come in, I want to see if that kind of helps lend towards that. So I'm just bringing up that point as well. They can be of different JSON formats. There's no bound schema, unlike SQL Server.
Exactly. So, like within a particular container, the only thing that has to be common between any two records is the ID field and the partition key. The rest can be completely different. Like I can store gobbledygook in one record. I can store like regular stuff in another record. Mix and match, there are no restrictions. And so, and again, when you go to a different container, you can use a different partition key. So yeah, so they call it schemaless. I call it more schema agnostic, but it's the fact that you're not bound to a particular schema. You can very easily shoot yourself in the foot with this. Like if you change your code and you have stored records with a certain fields and you remove that in future iterations of your code, there's a good chance that you may, if you're doing queries with that missing field, you may miss that entire section of records. So it's very easy to shoot yourself in the foot with this schema agnostic, but you can also evolve your databases easier with this type of approach.
All right, we have covered a lot of great questions as well after this. So this has been a great talk. All right.